Good day. Hi, I'm Jess. I'm about to discuss to you singly linked lists using Java programming. We'll be using NetBeans here. So with this one, a singly linked list is a linear data structure in which each element of the list contains a pointer which points to the next element in the list. It's literally a um, a process wherein it's left to right. Okay, so as you can see, this list contains node 1, node 2, node 3, node 4. Each node contains a data and a pointer component. Okay, so this pointer is also called next in programming. Later we're gonna do it. So the two components are the data and the pointer next. Okay, so the first node of this list is called the head, and the last node of the list is called a tail. So for this example, node 1 is the head of the list, and node 4 is the tail of the list. Each node is connected in such a way the node is pointing to node 2, which is turning pointing to node 3. And node 3 is again pointing to node 4, and node 4 is pointing to an undefined structure. Okay, so we will do the algorithm now by programming. Now, so you can see there is a program that I created here. I name my application as singly linked list. Okay, so first I will create a node for this linked list. So how will I do it? So I will create a class here, a class node. Okay, so with this node, it contains data and a next pointer. So data is an integer, of course, 1, 2, 3, 4. Node is next. I call it next here. Next is inside this one, I will create a node. So I called it public node int data. So this is inside the node, of course. So I'll name it here, and then this data is equal to data of this class. So this next is equal to, of course, null. Okay, so we're done with the node. Now we will represent the head and the tail, so by creating a variable for that one. Okay, so now I'll be showing it now. Public node head null semicolon, then public node node tail um, is equal to null. So I define already the head and then the tail. Next is I will add a node function, which is it will have the capability to add a new node to the list. So here I will create public void node function wherein this node function has an integer data. Ito yung parameter niya. Next, okay, so inside this method, I will have a constructor. Node will be the new node data. Okay, so we're in. I'll check first consent. So if the head is null, this is what I will do. This is the expression I will implement. So head, so head is equal to new node, and then tail is equal to new node. There. Next, I'll define my else here. Of course, if there's an if, I'll be using an else. So this is an if and else statement. So this tail has a next function, okay, equal to new node. There's an error. It's because my keyboard is not working properly. So this tail next, sorry about that one, is equal to new node function. So next is I will create a new node, and then it will become the new tail of the list. So how? Tail is equal to new node function. There. So done with the else. So I forgot a semicolon here. Okay. Next is I'm done with the else. Now I will create a call this uh, a display. So how will I do it? So public void display function. Okay, see, curly brace, which is a program again. So this display function, I will have a node current will point to a head. So this node current will point to the head, of course. And, okay, next is if if the head if the head is equal to null, then this is the process or the system will display system dot out dot print line list is empty. It's a string literal here. Okay, so clear it. So there, I'm good with the head. If head is equal to null, then I'll put a return value here. Return semicolon. And then what if there is a value inside the linked list? So instead of putting an output of list is empty, it's out that print line. It will print a value which is string node of singly linked list. Yeah, so it will print all the numbers. Okay, so with this one, I'll be using a while loop statement. While current is not equal to null, then it will display this code. So system dot out dot print line. Okay. Oops, only a print. Okay, sorry. So here current has a data plus string here, semicolon. So current I will initialize the volume is equal to current dot oops next semicolon. Okay, so here we're done with this one. There I call a system dot out dot print line here. Whoops, done here. So we're done with the classes. Now we will create the um, the driver class. So let's start with this one. So I will have a constructor, uh, the singly uh, linked list will have a new, excuse me, new singly linked list. Copy this one. It would be faster there. Method class. Okay. So there is I'll call the S list here. Put it here now. 1, 2, 3, 4. We'll be using the add node for this list. Dot add node function 1. Okay, so we'll be using this. It's much quicker. 2, 3, 4. So we'll run it. It's working properly. Okay, so okay, wait. How come? I'll restart. Wait. I'll check. Okay, just a review. Here is I created a node here a while ago. From here, I created the head and tail, and then also the next pointer. Next, I created an add node here. This will be used to define the head and tail. And then here, I created the display method here, wherein this will display all the node present on the list. And then this would be the driver class. Okay. So if I run this one, it will display 1, 2, 3, 4. It's because of this. Okay. See. So this ends the singly linked list topic. Thank you and good day.